In this video, we will try to understand, as you can see here on the board, on the pad here, is that straight line demand curve have different price elasticity of demand. We'll try to understand this concept. Why? We'll try to answer why is that, why it happens that on a straight line, as you can see here, there's a straight line demand curve. On this demand curve, why the price elasticity of demand is going to be different when you look at all the points. First of all, understand what is that. So there are three important points and five important elements are there. Number one, at the bottom, we know that the price elasticity of demand happens to be 0. The price elasticity of demand here happens to be less than 1. At the middle, it's going to be price elasticity of demand happens to be equal to 1. Above the middle of that straight line demand curve, somewhere here, all these points, price elasticity of demand is considered to be more than 1. And at the top, where it intersects the vertical axis, here the price of demand happens to be almost very high, and that is given here. So these are the different price elasticity of demand. In this video, we'll try to understand why is that. We'll try to understand a little bit mathematical way that is going to make it super easy for everyone to understand. Try, and then maybe you can replay this to understand the whole thing there. Before we start, before we get into the detail, one very important thing you have to understand, you have to memorize, or you have to remember, or you must have learned in the previous classes in maths, by the way, is that slope is equal to rise over run. How much it goes up, that you capture on, that is rise. Rise means the vertical axis, the y-axis, and the run is on the x-axis. But that can also be written, if you look here in this case, as you can see here in the diagram, rise is nothing but the price and run is nothing but the quantity. And so what we have done here is to change it to delta P over Q, as you can see here. Now let's try to prove this. Let's try to understand this. Maybe it's going to be very straightforward for you. So what we know that elasticity of demand, when you look at the elasticity of demand, we define it as, like, if you go, obviously you know percentage change in quantity demanded over percentage change in price, right? This is what the elasticity of demand formula is. That's how we define there. And so if you convert everything like that in this way, then it's going to be delta Q, delta P times P over Q. Now you can play with this if you want. You can get into the slow method there, and you can get into the detail. Like, for example, delta, how did I get this? You can say that delta Q divided by Q times 100, whole thing divided by delta P divided by P times 100, and 100 get cancelled, and then you will see that delta Q over Q, and then this upside down, it goes P above, and so you get this here. So this is something we have to understand this part. But then let's come to the straight line demand curve. Now when you look at the straight line demand curve, straight line demand curve, if you look at the formula, though it is not in your syllabus maybe, but then still this is what is going to help you understand, is like A minus, that's how we, the BQ, meaning to say that this is something like this kind of formula is applied if you want to get a straight line, if you want to give the equation of a straight line demand curve. Now if you apply from here, what we understand here is that when you look at this on a straight line demand curve, what is constant on a straight line? What is constant is the slope, and that slope happens to be minus b. You can see here, this minus b happens to be there. But then if I go back to this formula, can I write the elasticity of demand formula as you can see here, like minus 1 by b, because it says that if you see here, it says that delta Q divided by P and all this way there. So if I go back to this one here, if you see, slope is P over delta P over Q. And so here is the delta Q over P, and so I made it minus 1 by B times, okay, now that is something important you have to remember, that we have replaced that, right, isn't it? That we have replaced, and so after that what is left out? This one we replaced by this one, and so P over Q. And so this is very important. So what happened that when, let's go to the different scenario there. So when P is high, P is high, and P happens to be high, and then Q is low, right, isn't it? So P by Q is going to be large, and that makes it elastic. That will make the whole thing elastic, isn't it, when we will take the P high. And then the other way around, let's take when P is low, and then obviously Q is going to be high. That why? Because that's the law of demand, right? Like when P is low, when the price is low, the quantity is going to be high, that way. And so this being the constant, what is going to happen is that if you take P by Q, because P by Q is the only thing, 1 minus 1 over B is constant, is a constant, and so P over Q happens to be small, and so what is going to happen is that that's going to make it inelastic. So that's very, very important way. Here we can say that, okay, that's the explanation. What is the explanation? That if I take this straight line demand curve, which is P equals A minus BQ, that's the formula. What we know that A is a constant there, minus B is a constant there, because the straight line has a constant slope. But what is important is that P by Q, ratio of P by Q is changing, and when you look at the high, P being very high, the price being very high, what's going to happen is that P by Q will give you a large number. That is going to make it elastic. And we go to the bottom of the straight line demand curve, then in that case P by Q will give you a small, and that's why it's going to become inelastic. Quickly, what I'm going to do is to take one example. That's done. The explanation is done. You can skip now, you can leave now, but then if you want, you can understand with using a little bit more, apply that there. So I'll just take one example. Minus, let's say this is just one example. You are most welcome to take any and then try to understand that part. So this is the equation there. You can see there. So now what is happening is that here in this case, the slope happens to be, by the way, happens to be minus 2. Now, but then the point here is that what happens, let's take point, different points I will take there, okay? So different points I will take. So let's take 1.1. Let's take point 1 where the high price is there. High price is given here. Now, if you take that, so let's take a price P equals 80, right? If I take P price being 80, so if you take this 80, this will go this side, and all the calculations if you do, you will be able to find Q equals 10. Like, please, you can try that. You can try that, and this is what is going to be there. So now what is going to be the PED? PED, as we saw previously, right? We saw this is what the PED, right? This is what the formula of PED was. And so I'm like, this formula we can apply. This is a formula we can apply there. And so 1 minus 1 by B times P over Q. If you apply that, that'll be very interesting here in this case. So let's apply that. So we saw that this is minus 2. So this is going to be, if you take this way there, minus 1 by 2, because 1 by P is there. So 1 by B is there, sorry, this is the slope, B being the slope. So minus 1 by 2, and take the other P by Q ratio, 80 over 10. As I said that if it is there. And then in that case, what's going to happen is this will get cancelled, and that is going to be, it is coming out to be minus 4, but then it has to be, we ignore that, and so the elasticity is going to be 4, which is elastic. Let's take another now point, another one more point, let's take 0.2, and this is going to be, let's make it low price. Okay, let's make it low price. So if you take low price, what happens? Let's look at that. So and so let me take price being very low. Let's take this time. Earlier I took the price 80, this time I will take the price being only 20. So if you take price 20, what's going to happen is that 100 minus 20 will be there. 100 minus 20, 80, and that is equal to 2q, and so the q is going to be 40. Q is going to be 40. Now again apply the PED formula here. PED equals to minus 1 by 2. Remember 1 over minus b, again just to refer, 1 over, this is what we are looking at, 1 minus 1 over b, p over q. So minus 1 by 2 times p over q, 20 over 40, right? So now if you do this part there, so 20 over 40 happens to be 0.5, this is 0.5, and so that is going to be minus 0.25, right? Minus 0.25 ultimately is going to be, so elasticity is going to be 0.25, which is inelastic. So this is one of the ways. There are other ways also to understand it there. This is one of the mathematical way which can help you understand why on a straight line, go back to the first one there, why on a straight line the PED, the price elasticity of demand, is going to be different. That's the calculation here. Right, add your query if you have any, but that's the calculation. We'll see you in some other video, some other concept. Thank you.